balance equation. And what else? Okay. Okay, I think if you're here for the first time, you will find a way to join us, to follow. I think last time I was teaching balancing chemical equation. That was where we are. So I will continue from there. I think I balanced two types of reactions. I think I balanced have I? A balanced combination or words? Or words? Or words? Addition reaction. I say in this type of reaction, you will see a reactant A against B. What you will see is what? AB. So in a reaction where you have two reactants and they are just giving you a product, that reaction is a combination or addition what? Reaction. It can be elements. It can be compound elements. It can come in form of elements plus elements. And what we have here is what? Compound. It can also come in form of elements plus what? Compound equals to what? Bigger compound. It can also be in form of what? Molecule plus molecule equals to what? Compound. It can be molecule plus elements equals to compound. I think this equation can come in different forms, can come in these forms, all are still an addition reaction. I think in the first one, if I have something like, let's have, what is this? What is this? Iron is an element, plus what? What is this? Sulfur is also an what? Element. So the first one will have been sorted. But you know when you are balancing the equation there, you must take note of the fact that one of the participating reactants, like sulfur or iron, you should have a basic idea of the valency. Let's say iron is kind of not within the first 20 elements. This class is noisy. If I catch you making noise, you are leaving the class. Not to come back today again. Please be warned. Don't be an scapegoat. Don't take it poor. From here you go home. You never in our church. You'll be the first to leave now. You'll be the first now. Pay attention. So keep within our water. Don't tell me what in our water. That's what some of you start to tell me now. All right, listen. So of course you should know that sulfur is one element we are familiar with. As the sulfur is within first 20 elements. So it will be very easy for me to analyze sulfur very well and be able to deduce that sulfur tend to form an arrangement or configuration of what? 2, 8, and what? 6. This will help me a lot to tidy this equation. Are you there? So this is helping me now. I will have it that the valency is what? 2. So it has a combining power of 2. And this particular ion, the first oxidation state of ion is ion 2, isn't it? I think. So you're going to have this one. So remember, the element you are writing first is a cation. The element you are writing later is an anion, right? So this 2 is not just 2 in terms of oxidation state. The main state is -2. So this is what we have. What we have this as now? What's the opaque name of this compound formed? Now let me tell you something. For those of you that care to know, since iron is not in group 1 or group 2 or group 3 of the periodic table, I've told you before, element that falls from group 3, from group 4 and above. When you are naming such compound, you must name with their oxidation states. So if this man is -2, that means ion is +2, isn't it? So you must name with the oxidation state of ion there, which is what? Ion 2. So this is going to be what? Ion. That 2 must be parenthesis. Ion 2, the X there becomes what? You know, I told you that a compound that is formed by a combination of 2 atoms must end with what? IDE. I think I told you. So it's not going to be ion 2 sulfur. It doesn't make sense. But what? Ion 2 sulfide. This equation is balanced. Look at it here. How many Fe do you have here? Just one. And you have one here. Sulfur, so it's balanced. This is just a straightforward equation. So this is what happens if you are balancing an element and element. Yes? More than one valency. Well, yes. Like in the state of ion, you don't say have more than one valency, you say have more than one oxidation states. Of course now, sulfur have more than one valency. Sulfur have valency from -2 to +6. But you know one thing, if sulfur is combining with a metal, its valency is restricted, okay, maybe restriction. It will have a restricted valency of -2. That's what it is. But if sulfur is combined with oxygen, then depending on the number of oxygen, the number will now be what? Increasing. Let's see this as a case study. You see, with the 2 atoms of oxygen in that S, you cannot say that X is minus now, because that O is not a metal. It is a non-metal. Of course, you know that the oxidation state of oxygen, whenever you see it combined, is -2, isn't it? How many O is there? It's not 2. So -2 times 2 is not -4. The sum of the 2 atoms in SO2 must have a neutral state of oxidation. So if O there is total of -4, it means that X there is what? +4. So how do you name this compound now? You name this compound as sulfur 4 oxide. Have you now seen that the state of sulfur differs from the one we have here? But it all depends on the number of oxygen in the atom. It can have something like this. You know it's not going to be the same thing with this sulfur. So why this one is sulfur 4 oxide, this one is what? Sulfur 6 oxide. Are you with me? But if minus managed to be here, the nomenclature will change. How is the nomenclature change? You are not going to start with sulfur because of the negative, because it's not a radical. You will not start with sulfur, but you will start with what? Oxygen. How many atoms are you seeing there? So it becomes now trioxo. It will not end as usual ide. In this case, it will end with what? 8. If you see such kind of thing, it all will end. The element you're naming last will end in 8. So what is going to be now is what? Trioxosulfate. You find out it's not going to be 6. It's not going to be 5 either. It's 4, correct. I think you know how it's 4. Everything here is minus 4, isn't it? All things is minus 4, isn't it? Minus 2 times 3 is what? Minus 6. So what number will you add to minus 6 or give you minus 2? Which one? What number will you add to the minus 6 so that everything becomes minus 2? That's why it's trioxosulfate what? 4 ion. Are you with me? If the number changed to SO42 minus, what are we having there? Tetraoxosulfate 6 ion, isn't it? And so on and so forth. And that one is the highest oxidation state of what? Sulfur. How to know highest oxidation state? You have to check the group the element belong. It will not exceed 6. You see sulfur in which group? Group what? 6. So the highest oxidation number of sulfur is what? Is those of plus 6. So you can never see a sulfur with plus 7. It does not what? Exists. Like you can never see a carbon that is beyond 4. Have you ever seen carbon 5? Have you ever seen carbon 5? But you see carbon 2, you see carbon 4. That's the end. Have you ever seen nitrate 6 before? What will you see? Nitrate 2, nitrate 3, nitrate 4, nitrate what? 5. That's the ends. Alright, that is it for that example. In some cases you can see elements compound or compound elements. Let's say rather elements, sorry, change this man to okay, element compound. Which example are we going to use there? Which example? Remember what we're going to form must be a one product. That is what makes it combine. If we are to form 2 products, it's no longer a combination reaction again. We look for a type of reaction to assign that reaction. Is combination or synthesis or a reaction must be able to form how many products? 1. Okay, I've seen 1. I've seen 1. C is an element, isn't it? Matter state is what? Solid. Plus what? O2. Matter state is what? Gas. What are we having here? CO2. Matter state is what? Gas. Really? This one look like this one. So I'm not giving the right example. Let me find the example here. Element compound. Which element? Which compound? Which element? Which compound? That means I'll change it to molecule. Maybe that one does this. So molecule plus compound. So we can have what I have before. So what was it before? Okay, I want to have H2, a molecule, gas, plus C, 2H4. Who can tell me this organic compound? That is what? 18. Is it not 18? The reaction in which 18 reacts with hydrogen is called what? The name of the process in which hydrogen is added to 18 is called what? What type of reaction is that? What type of additional reaction is that? Hydrogenation. Hydrogenation. You see hydrogen there. You're using hydrogen to add to the compound. Is it? Do methyl. No, how can I do that now? I'm showing you molecule versus compound. Which one is methyl? Methyl is unstable now. Nothing like that exists. Methyl chlorine, how is it possible? Because we had a water chow. I'm not going to them now. Tell me, how would you want me to do that one? It's not the same thing with this one. Okay. Oh, yeah, listen to me. This reaction, how many products will be formed here? Which is ethane, isn't it? So it is what? An addition reaction. So what we have here now is what? C2H what? 6. Now you have added 2 to 4 now. So how many now? 6. So it's addition reaction. Are we going to add more numbers to balance the equation? Is the equation balance? It's balance. I call it equations, straightforward equations. It's balance. You added hydrogen. The hydrogen you are adding is what? Balancing the carbon-carbon double bond on the atom where the carbon exists. Then if we have this is a much bigger compound than this. If you have molecules, you often see that one like this. Then you have H2 plus what? Cl2. What are we having here? 2HC what? L. You don't say H2Cl2. You don't do that. Do you know what I mean by that? You don't say H2Cl2. It doesn't happen like that. Why? You must first consider the combining power. What is the combining power of H? What is the combining power of Cl? 1. We now must have combining power. Are you with me? What is the combining power of chlorine? 1. So there must be 1 HC, H1, Cl1. But for the fact that this is the atomic gas, this is the atomic gas, there must be 2. But don't alter it here. Are you with me now? You don't alter the structure. Put that 2 as a coefficient. Are you with me? Are you with me? What if it's a molecule and the elements? A molecule and elements will be just like I did before. Okay, Na elements plus O2. What are we having here? Remember, you have to consider. Don't say NaO2. Ibo is better cocoa. And you say it's balanced. O is 2, O is 2, Na is 1, Na is 1. Ibo cocoa. You must first know the combining power. What is the combining power of this man? And this man? You think I'll tell you how it's 2? Are you with me? So how does it go here? Na2O. I see what I'm saying? How do you make this O balance here? Do you go and put 2 here? If that 2 here, you have spoiled the reaction. Put that 2 here. That 2 will cover it and also affect sodium. So how many sodiums do you have here now? You come here and put what? 4. Equation is what? Balance. So that's for combination reaction. So why I just take time to give you this, you may see the reaction coming as element, molecule, compound, molecule, element, whichever way it is combination. Provided that there is only one product formed, the reaction is combination. But if 2 or more product is formed, the reaction is no longer what? Combination. And all these reactions you see here on the board are all what? Class redox. I think it was redox. That is a reaction where oxidation and reductions are going on at the same time. After all, I've told you that if an element is on its own, it is what? 0. Abi? Are you with me? Sulfur here has become -2. Then iron here. So as sum of oxidation number of all atoms of elements in a compound to be 0, this man is what? +2. Have you seen that the iron here has increased to +2? Sulfur here has decreased to what? -2. So the reaction in which the species oxidizes, another one reduced is a redox what? Reaction. I'll explain it again and again. I take a reaction in which oxidation and reduction is taking place at the same time in one reaction is what? Redox. A reaction in which oxidation and reduction is taking place at the same time in one reaction is what? Redox. A reaction in which oxidation and reduction occur at the same time in one reaction is called what? Redox. So you don't see in this reaction iron is 0. I think I've given you rules of oxidation number. Have I given you that? I think I've given you rules of where. If I've done that, it means that there's a rule that says oxidation number of an uncombined element. Like it's an uncombined element, it's not combined yet. But if an element is free, then the state of a free element like this free ion here is what? 0. Same thing with this one, 0. Then upon combination, in combination, since sulfur and oxygen belong to the same group, if combined oxygen is -2, combined sulfur is also -2. There is a rule that also says oxygen number of sum of atoms of elements in a compound must also be what? 0. So if sulfur is -2, iron will what? +2. Yeah? So that +2 and -2 give you 0. That's why if I'm naming the compound, I will name the compound as what? Iron 2 sulfide. So now see the reaction is in the sense that iron increased, sulfur decreased. It's not in all reaction you see decrease and increase. But when you see a reaction increase and decrease, that means the reaction is redox. All reactions like this are redox. All of them here are redox. How do you know it's redox? This one is what? 0. I think you know why it's 0? Because it is not combined. It's another element. It combined with self. This one can, this one is, all of this one is 0. Are you with me? Do you know why all of them are 0? Will I be saying one thing over and over again? I say that all atoms of elements in the compound, some of atoms of elements in the compound have an oxidation number of what? 0. But individually, what is hydrogen inside here? Is what? I want to know what is hydrogen inside here. Hydrogen inside here is +1. You consider for one atom first, and then consider how many atoms are in the compound now. 4. You now multiply later and have it that the sum of the compound that it is now is plus what? 4. You now say, okay, oxidation number of atoms of elements in a compound must be 0. Bearing that in mind, what then will be the number of carbon here? 1 carbon here. Am I free to say 1 carbon here is -2? So when I multiply by the number of carbon here, we have -4, isn't it? So that -4 plus 4 now will now give me what? 0. Therefore, also number of carbon here is -2. Why H here is plus what? 1. But later I multiply. Well, let's see what carbon is here. What is H here? Plus 1. Multiply by 6. What do you have here? Plus 6. Then what should be here? Minus what? Minus what? 3. Carbon here is -3. Carbon here is what? -2. -2 to -3. Has it increased or decreased? Increased or decreased? Decreased. From -2 to -3 is what? A reduction. Are you with me? From here, where it is 0 to where it is now +1, what has happened here? Oxidation. So it's a redox reaction. Yes? I should come again. Alright. Then back. have H2, which is 0. Bearing in mind that oxidation number of a free element and molecule is 0, plus C2H4. Sum of oxidation number of every atom here is 0. Are you with me? But sum of only H is plus 1. There's a rule that says oxidation number of hydrogen in each compound is plus 1. This is a compound of hydrogen now. But how many atoms of hydrogen is in the compound? 4. 1 times it by 4. What do you have now? Plus 4. Where? Then for atoms of elements in that compound to be 0, it will mean that carbon here is going to be what? Minus 2. I'm going to multiply this minus 2 and this 2. What will it give me? Minus 4. Minus 4 with plus 4 this side. Will it give me 0 now? 0. That's how we're able to find out that the oxidation number of carbon in this compound is minus 2. Then we'll now check the port we have here. C3, 2, H6. The same thing we do here. H here is 6 plus 1. Abi, multiply. What do you have here? Plus 6. What is carbon here now? Minus 3. It's minus 3 here. It's minus 2 here. We'll check what has happened here from here to here. Minus 2 to minus 3. Has it reduced or oxidized? Reduction. H is equal both sides. H here is 0. But H here is what? Plus 1. Like where is 0 here? Has this H increased or reduced? Because it has increased, it is what? Oxidation. So where a reaction, where oxidation occur at the same time reduction, the reaction entirely is called what? Redox. So addition reaction of hydrogen with 18 is a redox reaction. Are you with me? Is a what? Redox reaction. I'm teaching 2 topics in one. So you have to be very, very, your brain will see proper once. Are you with me? So you can prove this one yourself. Prove that this one is reverse reaction. Prove this one. Prove it. Are you proving? You don't even need to just waste. Just tell me, hey, you don't even need to look at this thing. You tell me it's reverse. You don't waste my time. H2 plus O2, is that what I have here? No. Cl2 is 2ACl. What is this one here? 0, 0. That is oxidation number, isn't it? H will become what here? Plus 1. Remember what it says? That if you see H in a compound, it's plus 1. How will you know chlorine here? Sum of the two of them must be zero here. So if H is plus 1, it means Cl is minus 1. There has been an increase from here to here. There has been a decrease from here to here. So this is a redox reaction. Are you with me? Do I need to prove this one to you? I don't need to prove it. You can prove it later. Let's go to another. This is what I did in the last lesson, isn't it? And let's recap it. And add new and also to it. Another reaction is what? Decomposition. I think that was where I stopped. I think that was where I stopped decomposition reaction equations. How to balance that kind of reaction. Is that where I stopped? Okay. Well, let's continue there. The assignment I gave you, I'm not going to talk about it. It's too simple. I don't discover I didn't think well before giving the assignments. All right. Let's go to that kind of reaction, which is what? What is this? Decomposition what? Reaction. It is opposite of the one we just finished here. The one we just finished now says A plus B, but this one is going to say what? AB is what? A plus B plus C sometimes, depending. If the compound is too many here, you're going to be having many, in which here is a compound, A or B may be compound, maybe a compound may come out, a liquid will come out, or sometimes gases may be involved. So whenever a compound splits, whenever a solid compound splits into a smaller compound, that smaller compound can go in three physical states. One may be what? Solid, liquid, or what? Gas. Imagine that type of chemical reaction is what? Decomposition. Are you with me? And then so many things will come up when you're balancing such type of reaction. You have to be very careful when you balance such reaction. I think I give you one or two reactions that are decomposable. Supposing we have a NaHCO3 and you are asked to balance this equation. I have to factor in what are the elements in this compound. You have sodium. If I try to split it, you split one, Na plus. You split this one as what? HCO3 minus. Because this one is being considered as if they are what? One. But you know, during the reaction, this cannot combine with this. Because if you combine with this, it will form the same thing here. It's not possible. So that's why heat is involved in this type of reaction. That's why we see something like this. So the heat will now help. This one cannot split again, because this is an atom. An atom is something that cannot split here. It can split again. So which one will split now? This one will split. It's going to do what? Split. The H will be released. Will what? Will come out. Let me use commoting. Then if you each step aside, bam, this one will magnet it. And if you each step aside, this becomes CO3 toward minus. I think you understand why 2 is coming, because coming there. Let me tell you how the 2 is coming. You know that this H is 1. This O is minus 2. Minus 2 times O is minus 6. You know this one is 4. By the time you add this 4 with this one, you add 5 here. 5 minus 6 is minus 1. But now that H is not there again. So you're now thinking of this person, minus 2 times 3, minus 6. Minus 6 plus a carbon, which is 4, give you what? Minus 2. The immediately this thing happen. The people without sites have not formed that kind of compound before. He will cite it. When he cited it, when he is carrying minus 2, he must carry plus 2 for them to be able to marry very well. You know why they marry very well? So the sum of the two, when they combine, becomes what? 0. Can you see 2 minus 2 0 here? How is this one going to come here? You know how here is what? Na what? 2. CO3 is just what? 1. The first one is coming. But you know that this is 2 here. You should go out and make sure that this one is 2. Then again, you know that this CO3 is numerous. It's down 2. So 1 has been used. The second one, this man needs to split into O2 minus O will come out here. Also, it's will come out here. H will be interested to combine. Remember, H is 2 as it is here. H will pick it up now that it's now neutral now. H picks it up to becomes what? H2O. What is remaining when O is now is a step aside from CO3, CO2. What end the reaction is what? CO2. By the time you do your atom counts, you see the number of atoms that are here is equal to the number of atoms that are here. But mind you, when the composition happens, it happens between a solid compound. When it is heated, it will split into compounds that may be solid, liquid, or what? Gas. Photo starts. Are you with me? I want someone to confirm to us if that reaction is reverse reaction. confirm it if it is a redox reaction. Ndị nkwari Okay, so for those of you, you'll be writing an exam in a very short time. You're prepared for nursing exam. I think I have your companion, your favorites, Shaw, catch up, shop log for your quick revision. I think I have up to 50 copies with me now. You can as well pick one. If you are writing any exam between now and November, including GCE, WAEC GCE, NECO GCE, even those that will be writing WAEC next year, I don't have enough copy. That's the only copy remaining on 50. And what we have in the office now is not even up to enough. You can pick one at 500 naira only. A quick revision guide to excel in all exams, external exams, UTME exams, screening exams. There is no way you write screening exam in chemistry. If a question are 20 questions or 10 questions, you will see 70% of your questions in my what do you call it? In my catch-up. It's called catch-up. It helps some of you that will be writing exam in 2 months, started now to prepare. I know what I'm saying. If you want to write screening exams like nursing screening exam, you're supposed to start preparing last 3 years ago. But because it is impossible for you to prepare for 3 years, people like us now prepare a material that have made the preparation easy for you at 500. In the next academic section, that book you see here will be sold at 1.5. So you pick it now that the offer lasts. Is what we can now, Try this one and let us see if we are catching up. If you're not catching up, you buy the catch up. To catch up. Let me see how many are catching up. But if you're not catching up, there's catch up textbook for you to catch up. Oh yeah, let's see those that will catch up. I said if you are not catching up, please pick this catch up file. You need to catch up 10 pieces. When I'm not catching this particular equation, you need to catch up 10 pieces. Whenever, okay, okay, you have not told me, you have not said if this one is redox reaction or not. It's balanced now. Do you want us to check if it's balanced? It's balanced. 2Na, 2H, 2C, 6O, 3 plus 2, 5. Sorry, 2 times 3. Is it balanced? 3 plus this one, 4. 4 plus 2 is balance. Is this a redox reaction? What is sodium here? Plus 1. What is H here? Plus 1. What is O here? Minus 2. What is C here? Plus 4. What is Na here? Plus 1. What is O here? Minus 2. What is C here? Plus 4. What is H here? Plus 1. What is O here? Minus 2. What is C here? Plus 4. What is O here? Minus 2. Check if the spreadsheet here, check if there's any change in the number. Is there any change in the number? What Na is here is same thing here. H is same thing here. C is same thing here. O is same thing here. So the reaction is not a redox what? A reaction. But can someone now conclude now that this type of reaction, which type of reaction is this? Decomposition. Will someone now conclude that this type of reaction is will someone now say that all decomposition reactions are not redox? Can we say that? No, we can't say that yet until we exhaust other examples. But this one is not redox reaction does not mean maybe this time will not be redox reaction. KClO3, balance this one. I don't want to put in something here for you. Be the one that will know what is coming out. Most exam bodies will give you the products on balance. You balance. But I'd like you to form the products and then balance. Learn how to do it. So tomorrow, some of you here will be teachers. So you know what you're teaching. So you will not go and teach with your notes. You carry notes, you'll be teaching. You want to write equation, you carry your note and write it. Kudi hand changing those balls, but let us akudi. How kudi? Nani and akudi go here. What is this man? K plus. What is this to? ClO3 minus. Are you still going to break this one down? No more going down. Are you breaking this one down? Yes. Break down. Come out Cl. Come out O. O is 3, you know. So it will be 3O. You know, when O is combined, it's minus 2. They are combined, no? They are combined. It's not that I'm separated, they are combined, but you need to separate it so you understand it. The one that comes out first is the one that protection will react with. Which one comes out first here? Cl. So you see the combination. KCl plus minus. So what comes with this out? KCl. Sharp, sharp. Eh? No, why the 3 will not be below again? The 3, the O has been separated from Cl. So the 3 can balance well. You see the point now? If the Cl is with the O, the 3 will be siding only the O. But now that O is now on its own, you can pick pretty big. If I want to write the equation here now, how many O are you seeing here? I want to write what? 3. O. But O does not exist as O. O is a diatomic gas. It might be what? O2. But problem don't they? O is 3 here. But how many O is here now? What did we have to balance it? To put what? That has also affected this man. What did we here? Put 2. Equation is what? Balance. Alright. And so what help us check if the reaction is a redox reaction. So what help us to check if it's a redox reaction. Is it redox reaction? Is redox. How? is plus 1. O is minus 2. Cl in the middle is what? Plus 5. K is still returning plus 1. Chlorine is what? Minus 1. Chlorine here adjusts what? Reduce. So write what? Reduce. O here is what? 0. But there's an O that is minus 2 here. So this O with this O here is as what? Oxidized. So this particular reaction is redox. So where this decomposition is redox, this one is not what? Redox. So one cannot say that all decomposition reactions are redox. But you can say some decomposition reactions are redox. Some. Just like we say all addition reactions are redox, we cannot do so in decomposition. In decomposition, we will see some decomposition reactions are what? Redox. While some are not redox. Are you with me? It is now your duty to now identify these decomposition reactions that are redox and those that are not what? Redox. Yes? You solve now. Sum of K, Cl, and O must be 0. But you already know from the rules the resolution of K is 1. O is minus 2. So what is difficult to know Cl now? If you know these two persons, now you can know this one. Since you find number that will make sure that all the numbers are adding up to 0. K1 minus 6. You check for a number that will add to 1. But if you minus 6 will give you 0. What number is that? That's what to know. Because now K is known as group 1. Sum of atoms of element in the compound is 0. So if you know that K is plus 1, then Cl is going to be what? Eh? Why are you asking me again? You know, you read book, you not read your book. You be asking question. Tomorrow, say, ask me this question again. So, are you with me? So, while you are addressing this one as a redox equation, address this one as non-redox. Please address it now. Address it. Address. Are we there? All this says boils down to the fact that the first 20 element is very important. First 30 element is very important. Those valencies, those numbers will help you a lot to know how these equations are formed. Okay. I think I'm done with the composition reaction. There are other types of reaction. There are what? Other types of what? Reaction. Let's look at double displacement reaction. Double displacement reaction. In double displacement reaction, you see something like this. Compound A, B versus compound CD. But over here, you will see AD plus what? Plus what? BC. This will happen here. A displaces. Who is it displacing? C and pick D. At the same time, B displaces D to form what? BC. Are you saying this what is happening now? There are reactions like that. There are what? Reactions like that. You don't see the point. So you see, this is compound plus compound equals to compound and what? Compound. Look at the phone now. It will cook now. Well, let me give you, I should do what? What am I explaining? What did I explain? AB is not a compound. CD is not a compound. A elements, B elements. When you have two or more elements, what do you call two or more elements? Compound. This is analog to what I want to explain. You know what I mean by analog? I'm using it to generalize that kind of equation. Then I want to now use an example. I want to assume that AB is watch this. N is H2SO4. Are you there? Are you there? Are you there? Are you seeing what I'm saying there? Let this A be this one. Are you with me? Because they're going to be seeing this one as if they are what? One. If you didn't do it like that, this will confuse you. You will not understand it from now till you die. Anytime you see these two, you start to differentiate them, you will not understand everything till you die. Do you get me now? You treat this one, these two as what? One. Failure to do so, you will not understand chemistry till you die. I'm telling you. Well, let's look for something as CD. Sodium hydro. I want to start with a simple acid base. This is what? Neutralization reaction. Well, let's see what's going to come out. You see what I mean by anytime you start to see this person as there are two, things will start to go well in your chemistry life. Well, let's see like that. Well, let's split it. What are we going to have here? About 2H what? Plus. The number that is here, make sure it is correct. What am I going to write here? SO4. What's going to be on top of this place? Make sure that this thing is 0. When you are doing it, this thing you did here, do it here. What do you have here? Na plus. Anytime you separate this one and this one, that is the day you start to be confused. That separates. So what you do here? OH. What goes here? Minus. What is double displacement? Double displacement is when two compounds react by exchange of ions. By what? Exchange of ions. Because you see the ions. You know that this man, who will this man combine with here? Is it this one or this one? And where's so for? Why won't it combine with this man? The light charge, they cannot even attract. So it will be attracted to this man. Make sure when the attraction is going on, make sure the charges, when combined, must be 0. As it is not 0. Jirakagi make complete 0 by putting what? 2 here. Therefore, what goes is what? Na2SO4. Rush here to balance this. Since this one is 2, come here and put what? 2. Then this 2 will go, Abi, plus 2. You must put 2 here, Abi. So when 2 of these come together, it becomes what? 2H2. Now, if you H, they will never 2 plus 2 here, 4. All you go 4 here, and all they will never 2. Then they will balance well and become what? 2H2O. Check this equation, it is what? Balance. Photocopy. So when you have a displacement double displacement reaction in which an acid reacts with a base to form salt and water only, what do you call this type of double displacement reaction? What do you call this reaction that produces salt and water only? You call this reaction what? Neutralization reaction. That's what we call it. want to write ionic equation on the reaction. Ionic equation on the reaction is what? 2H plus 2OH minus is equal to what? 2H2O. That's it. Ionic equation. Just this can use this plus this equals to this. Oil neutralization reaction. When you see this equation, it is called what? Neutralization reaction. Is in my jam ketchup. Is there? You see the reaction there? I gave this reaction. I said this reaction is known as what? Neutralization. This is seen as acid, a substance that produces hydronium ion or hydrogen ion. This is a base, a substance that releases OH ion. And when the two come together, what happens? The pH of this one is less than 7. pH of this one is greater than 7. When the two mix together, pH becomes 7. And 7 is what? Neutral. The process by which greater than 7, less than 7 becomes 7 is called neutralization reaction. Let me try you with this one. Let me try you with this one. Balance one, PB bracket NeO3 bracket 2 plus HCl. Here the reaction must occur in a aqueous solution. I'm going to balance this one. Okay, finish. All right. I'm going to let us see. PB, NO3, can we split? Consider this as 1. You see, I'm considering it, there are 2. I'm putting the right numbers. Alright? This is going to be what? PB. What will be here? 2 plus. Always make sure that the charges when you are splitting are equal to what? 0. Are you there? Plus what? HCl. Split as well. H plus Cl minus. What are we combining? Can I see the combination? You know you're putting 2 here. Share? Why? This is minus 2, this is plus 1. I think it's 0 and I think. So what is going to come out as what? 2HNO3. Are you there? But mind you, H is only 1, Abby. But it's already 2 here. What did you hear? You put 2. Abby? So when these 2 come to combine, plus 2 minus 1. What do you add here to balance it? 2. So what am I having here? Plus what? PB is 1. CLT is what? 2. You see that CL2 is automatically balanced? Is it automatic? NO3 2 is automatically what? Balanced in the acid. So this equation is what? Balanced. But in this reaction, this salt here is what? This salt is what? Is soluble. Whenever in a reaction between 2 compounds that are soluble and one of the product form, if one of the product form appears to be soluble, this type of double decomposition, just like this one, is called neutralization reaction. This one is called what? Precipitation what? Reaction. Why? Because this man is coming as what? White what? Precipitates. Photocopy. Photocopy fast. Are we there? All right. Try this one more. All right. This for you. This for you. this and see if you can balance this equation. You're going to form the products, and the products must align by the appropriate combining powers of the species coming over here before you think of balancing the equation. That means the product must be correctly written before the equation is balanced. It should be done by now. While you are doing that, you should also be looking at those examples there to confirm if the reactions from the whole. I think this is the second or third example so far. You have to check in the examples given. Check if this reaction is redox. Confirm if the reaction is redox. If it's not redox, you also confirm. You also have to give reason for that. So let's come to a conclusion. Whether we can say none of these type of reactions are redox, or whether we can say some are redox while others are not what? Redox. So that concluding part should be you that will find out. Okay. Okay, I hope it's not this one you are doing that's taking you this time. Well, let's go. Can we split? Can we split? How many AL? What was the charge on it? Abby? So this one going to be what? 3SO4. What is going to be charged on it here? Abby? Make sure the total net charge of these two is 0. Well, let's split this one. Of course, you know this one is going to be what? Na plus, Abby? This one is what? OH what? Minus. Are we exchanging? Are we exchanging? Well, let's exchange this one. Do you see? Check charge. Check charge. What do I have here to balance it? 2. So what do I have now? Na2 Abi SO4. Remember that all of them must be 3 in number. So what do I put here? 3. That 3 is because of this SO4 is 3 here. So that has balanced this SO4 here. But this is not balanced yet. What do you do to this person here? You add what? 3. No, now is so no. No. We multiply. How many? What will be here now? 6. So we are done with this side. Can we combine these both? Can we do that? Remember we add 3 here. Do you know why? I think. So now here is what? AL bracket OH bracket what? 3. And now, how many AL do we have here? 2. Can we put 2 here? Can we check if it's balanced now? How many sodium do you have here? 6. How many here? 6. That one settled. How many AL do you have here? How many AL here? I think 2. Balance. How many SO4 do you have here? 3. How many SO4 do you have here? 3. Settles. How many O do you have here? O. Let's check O. 4 times 3. 12. Plus 6. Total is how many? 18. Let's check if you have 18 O's here. 3 times 4. 2 times 3. Add all. Is it 18? Balance. Go ahead and check it now. Nothing, no more, isn't it? So the equation is what? Balance. Balance. So I'll tell you something. You'll be given such equation in exam. You see where we added numbers like here, here, and here. Examiner will just give you X, Y, and what? Z. And the question will be given a question like this. That's you, what is the value of X, Y, Z? So you have to balance all these things. So you cannot say that now X is what? 6, Y is what? 3, Z is what? 2. That is what you do. Confirm if the reaction is redox reaction. The charges are there for you to see. Here is 3. Aluminum here is 3. The numbers of the species here on the left is not is corresponding with the number of species on the right. So this reaction you are seeing here, these reactions you are seeing here, none of these reactions you see here are what? Redox. So whenever you hear double decomposition, please run for your dear life. They are not redox what? Reaction. So no redox reactions are what? Redox. All are not what? Redox reaction. Finally, on balancing equation. So, when you're balancing equation, you have to first know the type of equation you're balancing. Whether is it combination, whether is it displacements. We have 2 types of displacement. This is one of the type, double displacements. So I'm going to discuss another displacement, which is going to be what? Single what? Displacement. Single displacement. Are you there? So you have to see the reaction, know the type of the reaction before you now know which approach to use to balance the reaction. If it is this type of reaction, that means you have to be splitting to be exchanging. You split to do what? Exchange. If it's one reaction where you have compound, you have to be splitting and combine, until you see your products coming. Are you there? So that's what it do. What number now? What number? The last. I want to discuss the last type of reaction that we balance. What number? This is, you should be numbering this. I think with combination, decomposition. What else? Double decomposition is the third one. No, this precipitation and neutralization, they are under double decomposition. Are you there? This one and this one, they are under what? Double decomposition. Number 4, single displacement reaction. Single. You know, if you see single reaction, you see something like this. It's something like maybe A plus BC. And then you now see like AC. And then what? And then what? B. If the reaction is singly displaced, the only species that is displacing the other here is what? Is what? A. B was not an opportunity to displace anybody. So since, like in this one, as look at this, as PB displaces H displaces what? PB. You see, if PB displaces H, PbCl2 is formed. At the same time, H displaces PB to form what? HNO3. So you see, is what? Double. But there's some reaction, like for example, if I have something like A as what? Aluminium. Either, and then BC as H2SO4. This now. So what we're gonna happen here? What's happening here? Aluminium will displace what? H2. I know when aluminium is displacing, you should be mindful of the obstruction states now, isn't it? Aluminium will have plus 3. When you're getting minus 2, so what we have here is what? Al2. 2 of this will go to this man. Then bracket what? SO4. 3 will go to this man. Okay? And what happened to this man later? It becomes what? H2. But you must balance the equation. See when we are balancing, SO3 is 3, SO3 is just 1 here. What did you here? Put 3. Just for SO3 to balance. How many H do you have here now? 6, Abi. What will you put here? If you times it 2, you have 6. You put 3 here. Remember, this is 2, this is still 1 here. What do you do here? Put 2 here. Equation is what? Balance. Confirm if the reaction is redox. Reaction. Confirm if it's redox reaction. And of course, it's redox reaction because this man is 0, but here is what? 3. Oxidize. This H is 1 combined. Is not combined. From here is what? Reduce. So if it is single displacement, is redox, but if it is double displacement, is not what? Redox. And again, what is the driving force for you knowing who a species that is single will displace? What will be the idea for you to know why Al displaces H? The idea should be from the reactivity series. This is, you know, the reactivity series. Your reactivity series now. I don't need to start to explain it again. Reactivity series, potassium, sodium, you know what I mean now? So if you look at the position of aluminium, is above hydrogen. That was why it displaced hydrogen. If I give you this antibiotic to show me what's going to happen, KBr plus Cl2, what is going to come out here? You say, hey, is bromine and chlorine not in the same group? You find out. F, Cl, Br, and I. As you are going down, reactivity is decreasing. The most reactive is what? Fluorine. The least reactive is what? Iodine. It means in a reaction, chlorine is more reactive than what? Bromine. So chlorine will displace what? Bromine. And if it does displace bromine, what you're gonna have here is what? 2 KCl. Don't put KCl2 because combining power of K and this is what? 1. Well, because this man is 2, that's why it's 2. But that has affected what? Potassium up here. Put 2 here. Bromine is displaced as what? Br what? 2. This equation is what? Single displacement reaction. So you must know who will displace who from a reaction. How do I know that chlorine is the one displacing? Because of the position of what? Chlorine. Are you there? So I have touched key areas of equation. So I was doing even more difficult ones. I've been able to do the difficult ones. So exam bodies will just give you lists of what I've just. So that's it. Do you have any question? I wanted to switch immediately to ionic equations immediately. But looking at your brain, the way it is, can you still carry ionic equations? I still have a lot of time. Of course, now 12:30 now. I know some of you are lazy. Some of you can't cook a drone. I can have force soon. Don't so bad. Well, so there's no way we can do all these things without introducing ionic equation. I write it down. Ionic equations. Alright. Okay. Ionic equations. Right. In ionic equation, the species are balanced atomically. The species are balanced atomically. The species are balanced atomically. The species are balanced atomically and ionically. So the only difference between this one now and the one we just finished now is that in the one we just finished, we are only balancing atomically. Number of atoms. Once it corresponds, we are good to go. But this one, you not only balance atomically, but you balance what? Ionically. Some of the species will come with plus or minus. Are you there? Number them. Effort you put in place to balance equation is the same effort you put in balancing ionic equation. There is the same thing. The difference between ionic and the one we just finished now is the ion I added to it. Ion means a species carrying net charge in equation. Hey, not nice. For example, if I have Fe plus Cl2, I have Fe 3 plus 2 plus, you see now, plus 2Cl minus. What is this equation? Ionic equation. You see? It says ion 2. Are you there? That means something from that ion 2 is removed. Maybe it's ion 2 chloride. They removed the chloride from the compound, it becomes charged. They removed something here, it becomes charged. Maybe they equally remove something here. The only one here that is not being removed is this one. So when you see equation like this, it is what? Ionic. So how do we balance this equation? Simple. How many Fe do you have here? Forget the charge. Let's look at the atom. How many atoms of Fe do you have here? 1. How many here do you have here? Have you seen in this equation now, the number of atoms of Fe is balanced both sides. So you leave it. How many Cl do you have here? How many Cl do you have here? Have you seen that the 2 Cl on both sides is what? Balance. Let's check if the charge on both sides balance as well. Total net charge of this one is what? Plus 2, isn't it? Total net charge of this one is what? 0. I'm going to add this plus. All total is what? Plus 2. So let's see if this side is plus 2. Total of this man here is what? Plus 3. Plus total of this man here is what? Minus 1. But 2 there back here. Which give you what? Plus 3 minus 2 is equal to what? Plus 1. You have plus 1 here, you have plus 2 here. Is this in balance? You balance it. How do you balance it? Get the difference of charge between this one and this one. Get the difference. You write that one here as 1 E minus. Just write the 1 as 1 E minus. Then do the same thing here. What is the difference of charge between this one and this one? Eh? Minus okay? Write as what? 2 E minus. 2. Then, when you do these 2 generate, multiply your madna bar. When you want madna bar, multiply these 2. You balance the equation. Can we do it? Now, this particular ion generates how many electrons? 1. 1 times this is what? 1. 1 times this is what? 2. This one generates how many electrons? 2. 2 times this is what? 2. 2 times this is what? 2. Equation is balanced. Can we confirm now? Can we confirm now? So here is what? 2. 2 times plus 2 plus 0 is what? Is what? Plus 4. Let's go here. 2 will now go here, Abby? Abby? So this is not going to be what? Plus what? 6. Plus 6 minus 2 will give me what? Plus what? Plus what? 4. Plus 4 plus 4. Equation is what? Balance. Does it follow? Does it follow? Let me tell you. This one is the cheapest of them all. Forget the name. Hey, ionic equation, ionic. Leave it. Wait for another one. Wait for another example. Okay, look at this. We'll try if you can do this one. Okay, you wait for another example and grab it. Well, let me use this example to explain this one again. Well, watch this. Who am I connecting? I'll connect this one, Abby, and I'll connect these two. What was the difference of charge between these two? I'll write 3 here as 3E minus. What is the difference between this one and this one here? I'll write 2 here and put minus. The 2 was generated from who and who? This and this, Abby. Use the 2 multiplied by aluminium. Use the 1 aluminium generated to multiply what? Copper. So if I multiply aluminium by 2, and I'll multiply copper by what? 3. Equation is what? Balance. It's a trick. I don't understand the first one now. Does it make sense now? It's simple. Huh? All right. What's the difference? It's not that one that is there. Do you want them to have the same charges? Yes. Okay, try this one. And if you balance it, you tell me why has silver been reduced in the reaction? Why is silver reduced in the reaction? If you see that silver is the one that is reduced and copper is the one that is oxidized, why? You should know why all these reactions are going the way they are going. Ibalance here. What year remember? Look at it here. So there's a mistake. Oh. With this plus here, I cannot balance it. So what are the way? Difference. 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 So who is going to take these two? Silver. Who is taking this one? You see it's balanced now. Was it? The same thing boils down to reactivity series. In the reactivity, the thing boils down to reactivity series. In the reactivity series, silver is below copper. That is why copper reduces silver. Can't you see now? It boils down to the what? Reactivity series. So our assignment now is to go and study the reactivity series from potassium towards gold. To know why the reaction is like this. Are you there? So in the next class, we are starting with this. What's this? Stoichiometry of reaction. I think at this juncture I have to call it what? PD. P.